recording? I am recording. Okay. Everybody got it? How many squares?
I know 60-ish.
59, 60. Okay, 60 is a nice round number. Let's do 60. And then how much is each one? 1 times 25. So 60 times 25 is? 1,500 miles, right? So in those 8 minutes, you went 1,500 miles. Okay, so now now go onto your calculators here now, and let's go ahead and log in. So on your calculators, go ahead and you should be able to log in. Remember, it was your login. I think everybody knew that the other day. I can't remember if everybody had their calculator or not, but everybody should be able to. If you might have to go to home 5 login is just 5. That's a quick way from the home screen. 5, and then first 3, and then your last name, and then your student number should get in. Okay, looks like we're getting there. All right, so let's go to the next question, which says she thinks she's figured out her actual velocity equation, and it's given to you there in 3. Now notice it's got T's, you got to put X's. Let's all graph this. Okay, so go onto your calculator and graph it. And who's our presenter? Will is our presenter today. Thank you, Will. All right, so we're going into the graph screen, and we're going to graph, yes. Okay, so what do we need to see the graph? We need the same window that they have, right? So we got a nice window already set for us. It looks like if you did your X's from 0 to 10 and your Y's from 0 to maybe 300. So go into the window. So Will show us here as soon as he gets it typed in. But it's in menu and then window. This is one of the things you absolutely will have to do on the quiz next Wednesday. You will absolutely have to be able to give it a function, be able to type it into your calculator, draw a graph, set a window, be able to trace along there. Okay? What are you trying to do there, Will?
I typed it in and said it could be valid.
So you type in. Hit the tab. Usually as soon as you go to the window. Yeah, if you want the little entry screen, like right now, hit escape, hit escape, hit escape, hit the tab key. Well, go back to graph, that's fine. Go back to hit B for graph, or the scratch pad key. Remember the real easy way is the scratch pad key over here takes you back and forth. Scratch pad, hit it again, takes you back and forth between calculator screen. Now hit tab. Once you get to here, hit tab, and then it takes you to the next open place you can type in. Now up arrow, that'll take you to F1. So is there something wrong with your equation?
Plus 110.
Plus 110, okay. Otherwise, it looks good, doesn't it? Okay, hit enter. Now we're going to go to menu. Just hit enter. Yeah. Go to menu and window, and then we're going to go to window settings. Window settings, because we got a nice graph, right? I mean, they give us a nice window right here, right? 0 to 10. Let's go 0 to 10 on our X. And let's go 0 to 300 on our Y. And just tab is a great way to go from thing to thing, or the up and down arrows. Hit enter, and then we got a nice graph right there. Okay? All right. And then hit tab to close that. Should hit tab again. There you go. Okay? And there that is. Now, if you want to get this out of the way, you can kind of grab it with the trackpad, but I never do that because it's just kind of a pain. All right. So does this seem about right? Is that about kind of the graph that we had, right? It's pretty close, right? Looks pretty good. Okay, let's go up to number 4. So on your paper, it says divide the region from 0 to 8 into 4 vertical strips of equal width. Okay? Draw 4 trapezoids. Now, What's a trapezoid look like? Here's what they mean in this case by a trapezoid. Here's a strip and then that. That would be a trapezoid, right? So when they say a trapezoid, so you got your curve coming up like so, right? That's what they want you to do. So underneath that curve, but you're going to have these straight edges on the top. Divide that into 4 strips on your paper, Okay, so they want you to do this on your paper here. Go up to your graph and divide this into 4 equal strips. It'll be how wide? Well, 8's the total distance, but you're going to have 4 of them, right? So 2. They don't have to be real fancy. Okay. Now, is this, yes?
I can't get mine to show up like that graph.
Did you use X's?
When you put your graph
Yeah.
in, okay, go to your menu, your window.
Okay, now read the next question, read the rest of that question 4. Make sure you, okay, 0 to 10, 0 to 300.
So, 100. Just do that. Oh, you've got X, that's all up in the exponent.
You've got X raised to all of that. Okay? All right. Now, do you see what they're saying? I mean, how did we find the area before? Counted those squares. Would this be this would be an alternative to that, right? Couldn't we break this into 4 trapezoids, right? And here's the formula for a trapezoid: 1/2 the 2 parallel bases, which would be which the bases would actually be these vertical strips, right? The Y values, right? And then times the height, which the height of our trapezoid would actually be this right here, right? So what would be the height of each one of our trapezoids? 2. And then what would be these vertical strips? Well, they'd be these Y values. How could we quickly get these Y values? From our calculator, we could trace, right? So everybody get onto your graph, and let's trace at 0, and then let's trace at 2, and then let's trace at 4, okay? What do we get at 0? 110? Okay, what do we get at 2? 234. What do we get at 4? 238. What do we get at 6? 170. And at 8? Make sure you can do that now, everybody. Let's make sure we can trace. Looks good. Okay. So now menu, and it's all in menu. Everything's in menu when you're on the graph. Your window settings, your trace, those are the things you need. Those are in menus. Okay. We got to be able to draw a graph. I want to be able to do that. So let me know if we're having trouble. Well, right here, we want our X's to be there. So 0 to 10. Looks pretty good there. And then our Y's would be here. It looks like 0 to, 100, 200, 300 maybe. Right? Okay, sometimes you'll be given a window, but if you're given a grid, kind of like the Explorer 2, right? You had -5 to 5 and, on your X and Y's, and that's just how you set your window. Okay, but yeah, I want to make sure you ask about this because we want to make sure we can do that. So now we just trace and you just type in. So you just trace, so then you just go to your menu and then trace. Yeah, graph trace. Again, get comfortable with this calculator. I've got a thing we're going to do where you're going to have to do like a scavenger hunt on your calculator, so we're going to help you there. But I like to know, if I'm going to go to menu, I hit the menu button, and if trace is number 5, I'm going to hit the 5. I'm not going to hit that trackpad. I use a trackpad if you want. that darn thing, maybe it's my big dumb fingers, I don't have the coordination. Okay, so let's calculate each of those trapezoids. Okay, let's do this. If you haven't already, have you done them? You got the first one? Okay, you guys do the second one here. You two guys do the second trapezoid. You guys do the third trapezoid. You guys do the fourth one. Okay, give me the fourth trapezoid. So here's the formula. Here's your B1 and your B2 are these sides right here. And the width is going to be, the height will be 2 on each one of them. So, Jesse, what'd you get on this first one?
344.
344. Okay. As soon as somebody's got the second one, let me know.
472.
How much?
472.
472. So I'm just doing a trapezoid formula on each one of them. What about the next one? We got that one yet? Somebody else can do it too if we don't have it. How about the fourth one? Here we got it. 248.
Third one's 408.
408. Add those up. What did we get before? 1,500, roughly? We said 60 squares.
1472.
1472 sounds reasonable, right? Now, what's wrong? What's wrong with this estimate? You miss a little bit, don't you? You're missing a little bit because of the curve, right? You're not getting this amount right up here. You're missing a little bit here. You're going to miss a little bit here because this isn't exactly straight. It's curved a little bit. You're missing a little bit there, right? You're going to miss a little bit, but it's not bad, okay? It's not bad, and it gives us a geometric way of doing that because not every graph you're going to have a grid of squares, right? I mean, if you look at your calculator, there's no grid of squares there. You would have to have some graph paper with a grid to actually do a counting squares thing. So here's a way where maybe if we have the function, all we need are the y values, right? Think about it. All we needed there was the y values, which you can easily get from a function, and we can turn those into 4 trapezoids and do the area that way, but we're going to miss a little bit, okay? All right, so number 5, the technique in that problem is the trapezoid rule. So it says put a program into your grapher to use this rule. All right, well, I just happen to have written a little program. You computer science geniuses will appreciate this. We got a little program right here, okay? So it's a function, right? It's a function, a little bit like Python, right? I've created this function. I'm going to put this into what I call f1 of x, which it already is. I'm going to do some things here. And there's a little bit of math calculation down here, and away we go. But what you guys are going to do is just run this. So right now what I'm going to do is I'm going to send this to you, okay? And it's going to create a folder in your on your handheld. Let's see, I don't want to send it to myself. Let's send it, what the heck. We'll send it to everybody. Okay? All right, what are you seeing on your screen right now? Okay, it says file has been transferred. Now, you got some options. It says open, go to, and okay. Now, usually you do not want to do go to. Okay? If you're going to use it right away, you would do open. If you don't really need it right now and you want to get it later, you do okay. Well, let's do okay this time. Go to okay, because I want to show you where it is. So now go to your home screen. Okay, and on your home screen, go to My Documents. Okay, and you see the folder says AP Calc Block 1. Okay, and go ahead and open that. So highlight it, hit enter, and then under there it says Explore for Program. Highlight it, hit enter, and you should have this pulled up. Now be careful, don't type into here because then you'll mess up the program. Okay, but you should have that. Okay, go to your home screen. My documents. You went to do documents. So now you have an unsaved one, no big deal. Just in there. Okay? So you've got this document open. All right? Now, everybody got it? Everybody got this document? Is everybody on this screen right here? What I'm at right here. Okay, notice there's a 1.1 and a 1.2. Those are called pages. Okay? So section 1, page 1 and page 2. Now to get to this next page, you can use your trackpad, but there's a better way. You can hit Control and right arrow. Control right arrow will take you to the next page. Now that's just an empty calculator page, okay? But now we're not on the scratch pad now, see? We're not on the scratch pad, we're actually in a document, but it looks very much the same, okay? You can create different pages in there, graph pages, calculator pages, whatever. But usually we're not going to create our own documents. I will just send them to you when we need them. Here's what we're going to do. On the calculator page, we're going to call that program. So we're going to, it's called Explore 4. So we're going to type EXPLORE. Now notice how it goes bold right away because it knows that it is something that has been defined on that other page. Then we're going to hit our left parenthesis and our right parenthesis like so. Everybody with me? Okay. Now we're going to hit enter. And it's going to run this little program. Well, this program, one of the lines you might have seen in the program was request. Well, that makes a dialog box come up. So we're going to do, this little program is going to calculate the trapezoids for us. Okay? So our starting point is going to be 0, so hit OK. And our ending point is going to be 8. Did yours say 8? Because I'd already run this program before and put these in here, so these were the last values used. So that's why it came up with an 8. Usually you have to put your own in. Okay, hit OK. Now, how many trapezoids? I don't want to do 1,000. Let's do 4, right? Like we just did a minute ago. 4 trapezoids. Hit OK, and look what you get, 1472. Okay, so it just, what did it do? It plugged those, it figured out, okay, if you got 0 to 8 and you're going to do 4, each one of them is 2 wide. It went to 0 to 2 to 4 to 6 to 8. It plugged into the function. It got those y values back, put them into the trapezoid formula, added them up, and away we go. Now, remember we said 4 trapezoids is not going to be exact, right? We're going to be missing some. Well, what would be better than 4 trapezoids? 20 trapezoids, 100 trapezoids, 1,000 trapezoids, but boy, would that not be a lot of fun to calculate by hand, right? But the calculator would do a great job of that. Now, on your document, it says do it with 20 trapezoids. So all we have to do is hit enter because it'll just run the last thing we ran. So you just hit enter and it'll run the program again. So we want 0 starting point, 8 ending point, and this time let's type in 20. Okay? Now, if you could picture 20 trapezoids in your head, you get an idea of how much error would be there. You'd still be missing that little bit, right, above where it's curved, but it wouldn't be as much because you have all these little narrow trapezoids. 1,518 right there. Okay, well, you know what we're going to do. We're going to try, since the calculator does such a great job of this, what would 1,000 look like? Okay. Now, you have an idea of how much area is actually under that? You have an idea of the exact area that's under there? What do you think? What do you think the exact, because there is an exact area that's underneath that curve. What do you think it is? It's 1520. It's 1520. If we keep going, we're going to run out of decimals that the calculator will be able to handle. But you're getting 1519.9999999, right? That little tiny bit, no matter how many trapezoids you do, there's going to be that little tiny bit of error you're just not quite getting. But you're going to be able to see that it's heading towards 1520. And if we could actually do an infinite number of trapezoids and take out any of the error, it would be 1520. Okay? Think about that what we did with slope. Remember when we took 2 points really close together? And we could get closer and closer and closer? That's how we're going to do slope at one point. We're going to let the 2 points get so close together, infinitely close together, that we can tell what the slope is. Same thing with area. So that's how those two ideas are really closely related. We can approximate that area, but we can't get it exact, but we can get it so close to exact. This is one way to do it with trapezoids. We can do it with rectangles. We can do it with other shapes too. But we could do an infinite number of those and get the area approximation so close that we can see what it's approaching. The idea of that's called a limit. A limit. Well, if you read here, it says number 7, the exact value of the definite integral is the limit of the estimates by trapezoids as the width of each trapezoid approaches 0, as you get more and more trapezoids. Okay? And it says make a conjecture about the exact value of the definite integral. I think 1520 is a very reasonable conjecture. I think it's not going to go. What's going to happen is it's going to keep going 0.9999999. We're going to have that little tiny bit of error. But if we could get rid of all the error, it's a pretty good bet that it's going to be 1520. It turns out for this one, that's exactly what it would be. It would be exactly 1520. That's the error for this, or that's the area for this particular thing. Okay, a couple other quick questions here. Just getting to use your calculator. So let's go back to your scratch pad. Just go scratch pad, scratch pad. Let's see, I thought Will was our presenter here. I lost him. Okay, so go back to your graph here, Will, and everybody do this. Now it says, what is the fastest she went? Now remember, what does this graph represent? Isn't this her velocity, miles per minute? So what was the fastest she went? Where would that be? So trace to there, okay? This is something you need to be, on our next quiz, you need to be able to, not this stuff with the area and trapezoids, you're not going to do that, but you need to be able to draw a graph, you need to be able to trace along it and find some important points. Now remember I told you if you go real slow as you get up here, it's going to find the maximum for you. Keep going, boom, there it is. It'll pop up. There's his maximum, okay? So the answer to the question, what's the fastest she went? What number you got? 248.021, okay? The fastest she went. And then it says, at what time was that? What are you going to put? You're going to put 3.042. 3 decimal places. If you're giving a decimal answer, we always give it to 3 decimal places. So you're going to put that for how fast, and you've got to be able to read a graph. You've got to know what the units are. I gave it to you in the problem. You've got to know what the units are. You've got to be able to read and trace on a graph, and you've got to be able to interpret and know what the values mean. Very important. Okay, you were gone when we set this yesterday, so go to menu, go to 8 settings. Does everybody else show that number of decimals? Change that to plain old right arrow, plain old flow. And now, yeah, just hit enter. And there you go. Okay, everybody shows those decimals? All right, very good. Now, what was Ella's rate of change of velocity at 5? Approximately, what was her rate of change of velocity when t equals 5? Well, what's the first thing you want to do on your calculator? Trace to 5, okay? What was her rate of change of velocity? What's the word rate of change mean? Slope. Slope, okay? So, approximately what was her rate of change? One way to do this would be to just kind of draw a little line in here. I'm not going to worry about doing that right now. We don't have to worry about that. So, and because we're going to, when we get into chapter 1, but a little ways into chapter 1, we're going to talk about how we go ahead and calculate that. What we could do is take 2 points and do a quick slope, right? Just like we did on Explore 1. We could trace and we could write down this point. Well, let's do it real quick. Write down, under number 9, write down 5, 210. Okay? And now what would we want for our second point? Something really close. So type in 5.01. 5.0, rate of change of velocity. This is the velocity curve. We don't want they didn't ask for the velocity, they want the rate of change, which means slope. So now write down that point, and now do a slope calculation on those real quick. So hit your scratch pad, Will. Hit your scratch pad to go to the calculator. Okay, do 210 minus your other number, 209, whatever that was, hit enter. Just hit enter, that'll give you your Y. And now, that's divided by what, 0.01? Be 5.0, no wait, be negative though, wouldn't it? Be the other way around, be 5 minus 5.01, so it'd be negative 0.01, okay? So right about there, negative 35.1, right? Was she speeding up or slowing down at that time? Go back to your graph, hit tab. Now this is important. this is not going to be important for our next quiz. And I said, well, it could be. We've talked about this with velocity the other day. But what about, is she speeding up or slowing down? Why? Now, it's not because it's negative. No, it's not because it's negative. That's important to understand. Her acceleration is negative, okay? But why is she slowing down? Because this is velocity, right? And her velocity is going down, right? Her velocity is heading towards 0. That's why she's slowing down. Positive velocity, right? This is a positive velocity. Her velocity is 209 right here, right? 209 point whatever. She's got positive velocity, but she's got a negative acceleration. Those are acting against each other, okay? And so therefore she's slowing down. But again, not a big deal for the quiz to understand. But it's not just because the line's going down. It's because her velocity, her speed is getting less, and so she's slowing down. Okay, what time does she stop? Let's trace. Let's go down to the graph down there. I don't know, what's it look like? What do we do, 0 to 10? So just type a 10. Type a 10. Okay, type a 10.5. Later we'll find a way to get that exactly. Okay, she's now we're tracing, so we're, okay, when does she stop? Looks like right there, right? 10, look at that's the 0, 10.9161, right? Does she stop abruptly or gradually? What's it look like? Fairly gradually, because it kind of levels off there, right? But that's where she would stop because that's when the velocity is 0. But so it is important to be able to read off of a graph, know what these values mean, okay, and be able to interpret those numbers and what they tell about a story. That's definitely going to be something we'll do.
What did we go to change our settings for the amount of decimal places?
Well, I thought I did that for everybody. So go to menu, settings.
So it's
Yeah, and then, no, right arrow. And then float. Come yours looks different. And then enter, just hit enter. Okay, is that? Okay, keep, there you go. There you go. I think you were seeing them, I just don't think you were there. Go to, see, you're still in the document. Maybe that's why. We went to the scratch pad. But you're still in the document. Here's the scratch pad. But, which is fine. Okay, yeah, that's what it was. Yeah, that one's right. Okay. So for some reason it didn't change. So, yeah, that's right. Not sure what it is. Okay. All right. Let's. All right, good enough for that. Let's go. We'll go back to your notes here, and we're gonna talk a little more about exponentials. I want to do just a little bit of quick review on some trig stuff. So in your notes, okay, in your notes, write down those 6 problems here, and I just. Sometime between now and tomorrow, I want, and maybe you can do it as you're writing them, depends how good you are. I've put just some various things that are important to know, you know, the coordinates around the unit circle like we did yesterday. Emily talked about doing the 45, 45 to 30, 60 triangles, knowing those values might be helpful. Knowing that cosine is the x, sine is the y when you're going around the unit circle. Tangent, of course, is sine divided by cosine. Any of those things are useful, can be useful for these various things. So here would be 6 little values that you need to be able to just get without a calculator. And so I'm going to put those up there. You write them down, and if you need help with that on figuring those out and how to get those, I will be here at 4 o'clock. I'll be here after school. I'll be here tomorrow morning. You know, come see me about that. And we need to be able to get those
we need to be able to know those values. And that's just a sample, of ones we'd have to do. But
Okay, so was there some of that in one of the IXLs? You had to do some of that, didn't you? Okay, so I just wanted to throw this up here, and if you're concerned about finding those trig values and how to use these things, come and talk to me, and we can go through it. And again, I've got that trig review video that's up there, which kind of approaches some of this. It's a little older, so I may have even some other ideas. There's a lot of different ways you can do it. So do some of these. The thing I didn't put up there is just look at think of the sine graph. That's something we'll talk about here later on too. The basic sine graph that goes like this, and then like this, and like this, and so forth. And here's pi halves, and here's pi, and here's 3 pi halves, and here's 2 pi. That's your basic sine graph. And then also knowing your basic cosine graph, right? Those are, sine and cosine are the keys, because from there you can get tangent, and then from there you can get all the other secant, cosecant, so the real important ones are sine and cosine. All right, so I throw that up there. And then I would like to do an exponent. I'm going to take this, I'm going to go to a new page. If you need that, if you need any more off there, I'll put it up again later. Just ask me. I want to look at a basic exponential problem. So here would be you're going to be doing some of this today for some of your homework. So let's say we had a function f of x equals 20 e to the k times x. Okay? And I wanted you to find, and I also told you that f of 2 was equal to 80, let's say. Okay? So my question to you then would be find f of 3. Okay? Something like that. All right? Well, problem is we don't know what. We don't know what k is. But that's where we can use this to help us find it. Okay? So what would I write down? What would I do to help me do that? What would I do with this information? I'd write 20 e 2k, right? In other words, I would put a 2 in place of the x, right? I'm going to put a 2 in for the x. So that's going to be 2k. I don't think you want to write k2, right? I mean, that would be confusing because it might look like k squared, right? I think you should make it 2k, right? K times 2 would be 2k equals 80, right? F of 2, but that's 80, right? So 20e to the 2k would have to equal 80. This is a common thing we will have to do later on. Not going to have to do it on our next quiz, but later on we will, when we're working with exponentials, this is something we'll have to do with no calculator generally, right? If it's a calculator one, it's easy. We just go into our solve, right? We just go algebra menu, solve, we type this in, we figure out what k is. It's a piece of cake, right? But if it's no calculator, that's what I want to focus on right now. So how do we solve this? We would divide both sides by 20, which would give us this. And then what? Put it into your log form. Now, you got two choices. You can either put it into your log form. To be honest, what I usually think of instead, I think it just is more versatile and it'll work in a wider range of problems. Anytime you have an exponential, meaning you have a variable up in the power, do the log of both sides. That's what I'd rather think of, because it fits with what we're used to doing with the equations too. Do something to both sides. So do the ln of both sides. So you get this. Now, what's ln e to the 2k? 2k, right? That's the whole reason we did that, right? That's why we did ln. And then over here, of course, that's just ln4. And then we can divide by 2. Now, I would rather use fractions, not divide. Divide is messy. Divide, you'll learn throughout calculus, is messier. You're better off doing multiplication rather than divide. So if you got to divide by 2, you're better off multiplying by 1/2. Of course, we know what we can do to be honest. We can make this simpler on ourselves. What can we do with this 1/2? Put it in there. What's 4 to the 1/2? That's square root, right? That's 2. So this is just ln 2, right? Now, it's not because we took half of 4, right? Don't think we did that. We put 1/2 on as the power, and it's 4 to the 1/2 power, which is square root of 4. So we got 2. So k is ln 2. All right, so now what that means is my function is now 20e. So my original function is 20e to the ln 2 times x, right? Now what? Now plug in our 3. We want f of 3. So f of 3 would equal 20e to the ln 2 times 3. Now, that 3 I could actually put around in front of the ln, couldn't I? But at this point, I don't care about that. Now we're just rearranging. So here, I would say you could just stop. You probably could have just stopped with what you had before with the 3 over there. I actually wouldn't care. Couldn't we put that 3 in there? We could put that 3 in there and make it ln 8, but big deal. That doesn't do us. Well, no, that would do us some good, wouldn't it? Actually, that would do us a lot of good. Yeah, because now we have 20e to the ln 8. And what's e to the ln 8? That's just 8. So this becomes 20 times 8, which is 160? Because the power of logarithm, one of the things we talked about yesterday is the rule for logarithm. Same thing here. The rule on logarithm, when you have a number in front, you can move that in there as a power. Okay, so that was 4 to the 1/2 power. Here we can bring the 3 in there, so it's 2 to the 3rd power. So 2 to the 3rd is 8. Okay? Thank you for asking that, though. Okay? So, and then that becomes that. Okay? And so that's using those properties, so that simplifies down to just that. Now, if that wouldn't have worked out so nice, you wouldn't have had to do it. But, yeah, there you want to do it. It's 160. 160. Okay? All right. Anyway, that is something you're going to have a little bit of in your homework. Oh, one last thing that you're going to have in your homework as well. So there's going to be some work with exponentials, okay, some problems on exponentials. The other thing that's in here, there's going to be a few story problems. Now, I'm going to tell you right off the bat, these are going to be a little bit tough. The whole point of these story problems is getting them set up. The whole idea, now we're not going to really have to do this till chapter 4. This part's not going to be on your next quiz, but we want to introduce it because we get to chapter 4, there's going to be these problems, and the hardest part of them, it's kind of like back in Algebra 2, the story problems, getting them set up, getting your variables, set and getting them set up. So here's the problem. We've got a barn, and off to the side of the barn here, off to the south, I guess you would say here, is we want to enclose that with some fence. Okay, and we've got 100 meters of fencing. Now, we don't need any fence along the barn. So we only need three sides of this fence, okay? What I want is an equation for the area. I want a function that represents the area of the rectangular shape that we're going to use for this fence. In other words, how should I use my 100 meters? Should I come out from the barn and should I go, like this, and like this, right? And what would that area be? Or should I come out from the barn, like just here and use my 100 meters of fence? How far should I go? That kind of thing. Okay? How and And the calculus idea from that is, what would be the best use of my 100 meters of fence that would give me the most area? That's what we're going to go to. So what I would suggest is we just draw it, okay, like so, and we just label it. We say, okay, let's let that be X, okay, and what would this be over here? This would have to be X because we want a rectangular. And then what would this be right here? We could call it Y, but I don't really want two variables. I'd really rather have one variable. Remember, we got 100 meters of fence. It wouldn't be 2X. 2X would be involved. No. Okay, let me tell you this one. Let's say we use 30 here. And so that means we use 30 here. Then how much is going to be here? 40. Oh, how'd you get that? You subtracted, it's what you have left, right? So go ahead and say it again, Jess. Wouldn't this be 100 minus 2X? Right? That's the part we got to practice thinking. We let X, we usually want to just have one variable. So if this is X and this is X, we've used up 2X worth of fence so far. So whatever's left, 100 minus 2X has to go there. So now what's the area? Let's call it A of X for area. What's the area of that rectangle? Say that again.
100x minus 2x.
Yeah, you went ahead and already distributed it, right? But it would be just X times 100 minus 2X, right? It'd be length times width, right? It'd be X times that, which you're right, would be 100x minus 2x squared. And that's all they want you to do. They don't want you to actually solve it. They're just going to say, find a function of X. That's the language they would use in the problem. They'll say, find a function of X that represents the area of the rectangle. So what you're going to be doing on these problems most of the time is draw a picture. Now some of them won't need a picture, but draw a picture. But then let X, pick something for X. That's the problem most people have is they don't know how to get started on these story points. How do you get started? Well, pick X. Now, on some of the problems, they're going to tell you. They're going to say, let X be the price of the mug. Let X be the width of the rectangle, whatever. So they help you get started. But to get started, I just needed to put X somewhere. I could have put X here, right? I could have put X here and then figured out what those would be, right? But whatever. Okay? So there you go. So now what we can do is we can investigate that function. Now what happens is that's going to be an upside down parabola, right? X squared, doesn't that make parabolas? And it's negative. It's going to be an upside down parabola. So guess what? The peak of that's where the max is. That's what we'd be looking for, right? So we could graph this on our calculator. Maybe they'll have you do that. Graph it on your calculator or trace, right? Now we're going to learn some calculus ideas of how to actually get that back. All right. Here's what you're going to have for your homework. We're going to do the Appendix E, and I'm going to look and make sure these are the right ones I want you to do. But we're going to do Appendix E and Appendix G. Okay, Appendix E is the exponential function, and Appendix G are these story problems. So you're going to have to spend some time on these guys, especially Appendix G. I want to see, when I come around and look at your homework tomorrow, I want to see some pictures drawn on Appendix G. I want to see some things, some thought put into it. If you have trouble, get here early. I've got my solutions manual here you can look at. Okay. But an Appendix E is quite a few problems, but a lot of them don't take real long. But those are those exponentials like we worked on there. Of course, those they get a little harder at the end, like the one I just did there. But some of them begin more like the IXLs. Okay. All right. You can have the last 25 minutes to work here. Oh, and then I forgot. I'm also. This is a scavenger hunt on your calculator. This is not due until Monday. Put this up, write that down at the top of this. You're going to hand this in at the beginning of class on Monday. So don't forget about it. Okay? Hand this in beginning of class on Monday. Now, I will warn you. On this scavenger hunt. There have been some updates to the operating system since this was written. So when it says press menu and then algebra and then, it tells you what buttons to press,
they may have renamed some of them. It'll still be similar, but it may be renamed a little bit, so that's okay though, it'll make you kind of dig in there and figure it out a little bit, but you should be able to, it shouldn't be a problem. If there is one where you just can't find because it's changed or whatever, you can let me know, but, for the most part, I think it's pretty much accurate. All right, E and G for tomorrow, scavenger hunt for Monday. And here's the solutions manual. It's got the appendix, I think. Yeah, it's got some worked out stuff for the appendix problem. So if you get stuck on something and want to come up here and look at it, be my guest. Okay, on Appendix G, guys, let's skip number 1. Let's skip 5. Okay. So skip 1 and 5 on Appendix G.